Geotechnical can be categorized into soil mechanics and foundation engineering. The GATE weightage is 15 marks for geotechnical. The syllabus for geotechnical is this. In this video, we will cover 1 mark question and answer under the topic shear strength. Under the topic shear strength, more number of questions are to be covered. If we go through previous GATE question papers, at least a minimum of 1 question was found under this topic. Therefore, this topic will be of little lengthy. So, going into the question, number 1 was asked from GATE 1997. The ratio of unconfined compressive strength of an undisturbed sample of soil to that of a remolded sample at the same water content is known as. The ratio of its unconfined compression strength in the natural or undisturbed state to that in the remolded state without change in the water content, that is known as sensitivity. The option sensitivity is the right answer for the question. Question number 2 from GATE 1998. The stress strain behavior of soils as shown in the figure corresponding to. The respective options given for curve 1, curve 2 is: curve 1 represents loose sand and normally consolidated clay, curve 2 loose sand and over consolidated clay. As you can see in the options, they have stated over consolidated clay, normally consolidated clay. Hence, you must know what it is before answering this question. I have also explained about it under the topic consolidation, and also before studying shear strength chapter, it's recommended that you finish consolidation chapter, thus giving you more clarity on shear strength chapter. Assuming that you have finished consolidation chapter, here, getting into the question, they're talking about two curves. Let's study curve 1. While applying load, the strain is not changing much. There is no change in the soil dimension. But studying the curve 2, as you apply load, there is some gradual change occurring in the soil. Therefore, change in length or width or volume that is happening in the curve 2. Therefore, if you know what is meant by over consolidated soil, over consolidation is already been through some changes. When we study the history of the soil, it's been under some load for some time. Therefore, it has already gone through some changes in the soil. But this curve can be of a normally consolidated because it's newly applying some load, and with respect to that load, some changes are occurring in the dimensions. Therefore, curve 1 is of over consolidated clay. Of course, after a peak stress is received, a little bit change can occur in the over consolidated clay, and thus after some time there is no change at all in both the curves. Therefore, coming to the options, after studying the curve, we can understand that curve 1 is talking about over consolidated clay and curve 2 is talking about normally consolidated clay. But whether it is dense sand or loose sand, that is another thing we need to know. For curve 1, if you take the history, it is subjected to loading. Therefore, the soil underneath has been compacted well, so it will become dense. Therefore, the dense sand and over consolidated clay should be the curve 1. And curve 2 is currently undergoing loading. There is no past history. Therefore, the sand will be of loose one. Answer for this question is option C. But make a note of this curve in your formula notebook. It will be useful that this particular curve represents dense sand and over consolidated, and this curve is representing the loose sand and normal consolidated clay. From 2001, the following two statements are made with respect to different sand samples having the same relative density. Identify if they are true or false. These are the two statements they have stated it. Poorly graded sands will have lower friction angle than the well graded sand. The particle size has no influence on the friction angle of sand. There are some terms here that you should know from the previous chapters. That is poorly graded sand, friction angle, well graded sand. Therefore, you must know what is mean by all these terms. Well graded in the sense it has smaller particles and also other sized particles. So there is a size variations between the soil particles. They easily get bonded and they arrange well. Therefore, this is well graded. For poorly graded, when all the particles more or less of same size. Particles are of same size. Therefore, they don't form a good arrangement between the soil particles. There is no good bonding between them. Therefore, that soil is called poorly graded soil. This gradation of soil will affect some of the properties of the soil, that is compressibility, shear strength of the soil, and further the shear strength is governed by two parameters of the soil. One is cohesion and the another one is internal friction of soil. This angle of internal friction is what affected by the gradation of the soil. So the size of the particle will affect the friction angle. That well graded soil will have higher friction angle. When poorly graded soils has less interlocking between the particles, they have only lower friction angle. Therefore, if we understand that gradation is affecting friction angle, therefore we can say statement 1 is right and statement 2 is false. Option D is the right one for us. Statement 1 is true, statement 2 is false. In the year 2004, GATE question asked was the undrained cohesion of a remolded clay soil is 10 kN per meter square. If the sensitivity of the clay is 20, the corresponding remolded compressive strength is. This is one of the methods to find the shear strength of the soil. Before answering this question, kindly go through the laboratory test and the formula that is used under unconfined compressive strength. In the unconfined compressive strength, for the laboratory understanding, I am just telling a gist. Taking a soil sample, we apply load from the top, and that stress what we apply is known as sigma 1. And also, in the previous triaxial test, if you take and read a triaxial test, how it is done, there they apply from the horizontal ways, they also apply a pressure. That is known as confined pressure. That will be taken as sigma 3. But in the unconfined compressive strength, we don't apply this sigma 3. We only apply from the top, that is deviated stress. Therefore, sigma 3 is 0 in the unconfined compressive strength. Some of the formulas under unconfined compressive strength are here. To find unconfined compression strength, that is represented as QU, it has a formula of QU equals 2 into CU. CU is nothing but the cohesion. I already said shear strength is governed by cohesion and internal friction. Here the soil that we are testing here under the unconfined compression strength is clay. We use only clay for this unconfined compression strength. Therefore, phi angle is 0 for clay. And hence in the equation this term will become 0. Only the remaining portion is QU equals to 2C. Therefore, I have taken the formula and substituted the given data and I have got 20 kN per meter square. The answer for our question is 20 kN per meter square. Here in this question, they have also given sensitivity value in our question, which is not required for us to find this compressive strength. Next question from GATE 2004. In an undrained triaxial test on a saturated clay, the Poisson's ratio is. For a saturated undrained clay, mu will be nearly equal to 0.5. So if we just go through the options, sigma 1 is greater than sigma 3. So I am assuming a value, let me take a smaller value, sigma 1 to be a 2, sigma 3 to be 1. Just an assumption. And hence, if we just substitute in option D, we will get the value to be 3 by 1, which is greater than 0.5. So this option D cannot be our answer. Let's check option B. B, again option B, this is sigma 3 is 1. So 2 minus 1 is 1, which is greater than 0.5 again. And checking again C, you will get again 1, which is greater than 0.5. Coming to option A, it will give you nearly equal to 0.3, which is in the range of Hence, option A is correct for our question. Next question from GATE 2007. A clay soil sample is tested in in consolidated drained condition at a cell pressure of 100 kN per meter square. What will be the pore water pressure at a deviated stress of 40 kN per meter square? Keenly reading the question, we will understand consolidated drained condition. Therefore, there is no pore water pressure developed in this particular test, and hence the pore water pressure here is 0. Next question from GATE 2011. For a sample of dry, cohesionless soil with friction angle phi, the failure plane will be inclined to the major principal plane by an angle equal to. It will be more easier for you to understand after studying the Mohr circle, and this is the failure plane in the Mohr circle is represented by alpha, and this alpha is found by using the formula 45 degree plus 5 by 2. So this is the formula we need to use to find the angle of failure plane. The right option is D. Next question is from GATE 2012. The effective stress friction angle of a saturated cohesionless soil is 38 degree. The ratio of shear stress to normal effective stress on the failure plane is. To answer this question, we must know what Coulomb has defined for a shear strength. According to Coulomb, he gave a definition and equation that shear strength S is equals to C plus sigma tan phi. It is also represented as tau F, and in our question they have stated that it is cohesionless soil. That means cohesion C is 0. Here this is the given. Phi they have given 38 degree, and C it is cohesionless, C is 0. Just by substituting in the equation we will get the ratio of shear stress to normal effective stress. Therefore, S equals to C plus sigma tan phi. I have substituted the given and I got the ratio to be 0.781. Option A is right. Next question is from GATE 2014. For a saturated cohesive soil, a triaxial test yields the angle of internal friction phi as 0. The conductor test is. The first option, consolidated drained test, usually done on cohesionless soil, that is sand, and consolidated undrained test is done to check sudden drawdown in the earthen dams. And the other two tests is the two tests that you need to decide between. Unconsolidated undrained test is a suitable one because the unconfined compression test is a test that we do to recheck the value that we got in this test, just to check if the values are remaining the same. So that unconfined compression test is just a recheck. Question from GATE 2015. Which of the following statements is not correct? Loose sand exhibits contractive behavior upon shearing. Dense sand when sheared under undrained condition may lead to generation of negative pore pressure. Black cotton soil exhibits expansive behavior. Liquefaction is the phenomenon where cohesionless soil near the downstream side of dams or sheet piles loses its shear strength due to high upward hydraulic gradient. Liquefaction usually happens or occurs due to earthquake or some other vibrations that may be occurred due to the machines that work nearby the site. That only causes, those vibrations will cause the liquefaction effect in the soil, not the upward hydraulic gradient. Therefore, option D is the right one. because that liquefaction statement is wrong.